1.3, we are graphing linear equations and inequalities. So yesterday we were just graphing our answers. Today we're actually doing this on a graph so they're linear. So it's not just an x or y. We have both x's and y's now. Okay, so a couple definitions first for you. We need to know what the y-intercept is. The y-intercept is the point where the graph crosses the y-axis. So it's that point where the graph crosses the y-axis, and I'm just giving you these two so that we can remember kind of some of these key definitions. Okay, so going along with y-intercept, you guys should remember slope-intercept form. So our term here is slope-intercept form. What was it? Our good old friend y equals mx plus b. So if slope-intercept form, if you associate that with just y equals mx plus b, I'm happy. M is your slope, and remember b is your y-intercept. Okay, so y equals mx plus b, m is the slope, b is the y-intercept. We actually have two kinds of forms for a line. We have y equals mx plus b, that's slope-intercept. We also have what's called standard form. Standard form is ax plus by equals c. So a, b, and c are all numbers. So there's a number in front of x, there's a number in front of y, and they're equal to a number. But we have to remember that a and b cannot both be 0. Okay, so that's just a math kind of add-on to the end. A and b cannot be 0. Okay, so that means we actually do have to have x, at least x or at least y in there. Okay. Okay, so one more definition for you. We have a y-intercept, so we also have an x-intercept. If the y-intercept is where the graph crosses the y-axis, where do you think it crosses at the x-intercept? At the x-axis. So the x-intercept is where the graph crosses the x-axis. How do I graph an equation in slope-intercept form? I will highlight the important phrases for you, okay? And I will paraphrase. Okay? So what we need to know is this is for slope-intercept form. So when something looks like y equals mx plus b, okay, so for y equals mx plus b, these are the steps. Step 1. You want to make sure that it's in slope-intercept form by solving for y. Okay, so get it to y equals mx plus b format. Okay? So solve for y so that it's in y equals mx plus b. That's a paraphrase for you. Solve for y, so y equals mx plus b. Okay, it's not always going to be in that form. Okay, step 2. You want to identify the y-intercept and use it to plot the point. So you want to find the y-intercept and plot the point. Okay? So figure out, plot the y-intercept after it's in the correct form. So that's step 2. So step 1 is solve for y, get it to y equals mx plus b. Step 2 is plot the y-intercept. Step 3 is identify the slope and use it to plot a second point. So plot a second point using slope. Okay. Step 1, solve for y to get it to y equals mx plus b. Step 2, plot the y-intercept. Step 3, use the slope to plot a second point. And slope is what? Rise over run. So we can just count, correct? So slope is rise over run, so that's how you're going to get your second point. And then step 4, draw the line. Okay? So these are the important phrases for you. I'll paraphrase once more. Step 1, solve for y, get to y equals mx plus b. Step 2, plot the y-intercept. Step 3, use slope to plot a second point. And then step 4, draw the line. Example 1. We want to graph y equals negative 3 over 2x plus 1. So what I suggest is that on your notes you put put the example in the actual problem because on this sheet that I gave you, there's not a ton of room. So write down the example, show the work on your notes, and then just do the graph on here, okay? And then my suggestion is, I've seen students before cut this out and glue or tape it onto their notes, or as long as you label number 1, 2, 3, whatever, you staple it to the back, and then you have the graph, okay? So you can do a couple different things, okay? Okay, so step 1, we need to get it into slope-intercept form. Is this in the form y equals mx plus b? Yes, it is. So step 2, we need to figure out what b is and graph it. I see two numbers here, -3/2 and +1. Which one is the y-intercept? +1. So what I do is I actually put a box around the y-intercept, okay, and then I write it right here, b equals 1. So how do I graph that? It's the y-intercept, so it's going to be on the y-axis. So from 0, I just go up 1 space. So if +1 is my y-intercept, what is my slope? -3/2. So I circle the slope. So slope is -3/2. Which one is rise? -3 or -2? -3. So just for right now, I'm going to label it. So that means 2 is the run. And it doesn't matter if your negative is on top or bottom. I always just stick it on top because then it's consistent. But it could actually go either one. It doesn't matter. Okay, as long as one of them has the negative. Okay, so because this is slope to plot the line, I don't start at 0. I have to start at the point I already plotted. So I put my pencil on that point. And since this is the rise of -3, I go down 3. 1, 2, 3. And then don't put a point there because we still have to go over 2 spaces. So that's positive. So 1, 2. And then you can plot a point there. So 2 points is enough, so we draw our line. And one thing that you guys need to make sure you remember is how long do lines go on for? Forever. So make sure you put those arrows at the ends to indicate that they go on forever. If you don't, then it's just a line segment and it's not the same thing. Okay, so put the arrows at the ends to make sure that we know that they go on forever. Okay, and that's how we plot in slope-intercept form. Do you guys remember this from Algebra 1? Okay. What happens if our equation is in standard form? So there's 4 steps for that one too. So if our equation is in standard form, that means we have x and y on the same side. So ax plus by equals c. That's what it looked like. X and y are on the same side. First we need to make sure we write it in standard form. And actually I'm just going to write a note down at the bottom. X and y are on the same side. So x and y are on the same side. Step 2, we want to find the x-intercept. So you want the x-intercept and plot it. And a hint is, if we're crossing the x-axis, y will always be 0. So you want to plot the x-intercept by plugging y equal to 0. Step 3, we do the same thing, except this time we're looking for the y-intercept. So x is equal to 0. And then step 4, you draw the line through the 2 points. So step 1, we get x and y on the same side. Step 2, plot the x-intercept, y equals 0 there. Step 3, plot the y-intercept, where x equals 0. And then step 4, draw the line. So example 2. Once again, I suggest you do the work on your notes, then just put the graph on the graph paper I gave you. So we have 2x plus 3y equals 12. That's our equation. Is this in standard form? Are x and y on the same side? Yeah, it's already in standard form. This is what standard form will look like. X and y will be on the same side. Okay, so that's what we want. So what I do to find the intercepts is I make a t-chart and I label one side x-intercept and I label the other side y-intercept. This is just to keep myself organized and so that I know which one I'm actually solving for. Okay, a hint, your x-intercept will be x equals something and your y-intercept will be y equals something. Okay, so if I'm crossing the x-axis, here's my x-axis. All my x's are a number, but what is y for every single one of these? Y is 0. So if I plug 0 in here for y, what's going to happen to that entire 3y? It's all going to be 0, right? So what I do is I use what's called the cover-up method. If I'm looking for the x-intercept, I know that those y's are going to go away, so I just cover it up, and what do I have left? 2x equals 12. So that's what I'm going to write down here. Okay, so along the x-axis, y is always 0. So I can just take away all those y's. So I'm left with 2x equals 12. Now this is really easy to solve. How do I solve that? Very good. I divide both sides by 2. So that gives me x equals 6. That's a point. That is 1 point all by itself. So along the x-axis, let's plot that. 1, 2, 3, 4, 5, 6. And I'm actually going to label that x-intercept. Just for right now, just for this one time so that we have it labeled. Okay? We do the same thing for the y-intercept, except what am I going to cover this time? The 2 x's. Because notice, on the y-axis, this point is 0, 0. This point is 0, 1. This one is 0, 2. So the x's are all 0. So the x's go away. So I'm left with 3y equals 12. And then this process is the same here. I divide both sides by 3. Those reduce. So I'm left with y equals 4. So that's along the y-axis. This is a separate point. These are 2 different points. Do not combine them into 1 point. Okay? So from 0, 0, I go up 1, 2, 3, 4. And that's your y-intercept. Two points is enough, so I can draw the line between the two. And that's how I graph one that looks like that. So we have 2 different types of equation, of linear equation. For each one, we have a method to graph it. Okay? So there's not going to be any having to maneuver everything around. If it looks like this, x and y on the same side, just do the t-chart and use the x and y intercepts. I almost guarantee that every time the numbers will come out nice. If it's y equals mx plus b, do what we did in the last example. Okay? So you have 2 different methods of graphing this time. Okay, Okay, so we have 2 special kinds of lines, horizontal and vertical lines. Horizontal, can anybody just raise your hand and tell me, is horizontal up and down or side to side? Horizontal is side to side. Where did I draw that? So a horizontal line will be y equals a number. So if it's ever just a y equals, there's no x's, it's a horizontal line, it's going to look like that through whatever number that is. Okay? A vertical line is always going to be x equals a number. So x equals no y's, that's a vertical line. If you have y equals with no x's, it's horizontal. And vertical is up and down. Okay, so those are 2 special lines that I guarantee will be asked of you on the test. Okay, so example 3, I give you 2 lines. A is y equals -1. B, x equals +2. So both of these are one of the 2 special cases. Write it down. I'm going to show you how to figure out which one's which in case you can't memorize it. Okay? so if you can't memorize it, we can do test points. So for A, notice how this says y equals -1? That means that y, no matter what x you choose, will always be -1. So let's graph a couple points, and that'll help us see if it's horizontal or vertical. So I know that y has to be -1, so somebody give me an x. 4? Okay, so let's graph 4, -1. Will you graph that point? 1, 2, 3, 4, down 1. Okay, now we need 2 points to graph a line, so we need to pick another x for our y of -1. Somebody give me another x. 2? I'm surprised nobody picked 0. 2, -1, that's 1, 2, down 1. Is that enough points to draw the line? Yeah, so draw a line between the two. Okay, and it's a horizontal line. So if you ever forget, you can't memorize which one's y and which one's x, just pick 2 points, any 2 points, and graph it, and that will help you. So you can plot 2 points to help you as well figure out what type of line you have. This just means that y will always be -1. Does that make sense? Okay, so for part B, I don't know why I just stuttered. For part B, we have x equals 2. So that means x is always 2. So I know that x is 2. So somebody give me a y, any y. 7. So let's graph the point to 7. 1, 2. 1, 2, 3, 4, 5, 6, 7. And then let's pick another point. Remember, x has to be 2, so we can choose any y we want. -4? So that's 1, 2, 1, 2, 3, 4. Oh my gosh, it's a vertical line. Okay, so it will always work if you just plot 2 points and to make 100% sure. So I would suggest plotting 2 points to make sure instead of trying to memorize it. I saw last year in my Algebra 2 classes on a lot of tests, because it said x, they just went side to side through that point. So this one they graphed as a horizontal through +2, when they could have easily just checked a couple points to make sure. Okay, so I suggest that you check 2 points to make sure, just to make sure that you don't lose those points on a test or on your homework. Okay, so those are our special lines. Okay, so now we have to look at graphing inequalities. Okay, so we graphed equations, now we're graphing inequalities. So what does it mean to be a solution of an inequality? A solution of an equation means that that point lies on the line. But an inequality is a little bit different because it can be anything less than this number. So it can be more than just one answer. So a solution to an inequality is an ordered pair, x and y, that make the inequality true. That's what the solution is. Okay, so this example 4, doesn't have graphing in it. We just want to check whether the ordered pairs are a solution to this inequality. So I give you 2 ordered pairs. We need to check the solution to that one inequality. So what do you guys think I'm going to do? Any suggestions?
Plug it in.
Just plug it in. That's all we're going to do. So an ordered pair is x comma y. So we're just going to plug in 3 for x and 2 for y. So for A, we're going to plug in 3 for x. So that's 4 times 3 plus 2 times 2. And we want that to be less than 6. So if we, or greater than 6, sorry. So if we get a true statement, it is a solution. If it's a false statement, it's not a solution. Okay, so let's look at this. 4 times 3 gives me 12, plus 2 times 2 gives me 4, greater than 6. What's 4 plus 12? 16. Greater than 6. True statement, yes or no? Yes. So 3, 2 is a solution. Okay. Will you guys check -1, +4 for yourself? So plug it in, check to see if it is a solution. How many of you got that yes, it was a solution? How many got no, it's not a solution? Okay, good. Here's my work. What I did here was I plugged in -1 for x, +4 for y. So I had 4 times -1 plus 2 times 4 greater than 6. That was what we wanted. 4 times -1 gives me -4. 2 times 4 gives me 8. Greater than 6 is what we want. What's -4 plus 8? +4. But is +4 greater than 6? No, so it's not a solution. Okay? So if it's a true statement, yes, it's a solution. If it's a false statement, no, it's not. Okay? We are going to use this in our graphing. So this is the last set of notes before it's just examples. Okay? So a couple more steps. How do we graph inequalities? Okay, I'm going to paraphrase again. Graphing inequalities, step 1. The thing we have to know about graphing inequalities is you actually graph the line the exact same way that we just learned. So it's either going to be a standard form or slope-intercept form. So you just graph it the same way. The only thing that's different is that because we're inequalities, sometimes we're just less than or greater than, but sometimes we have that equal to underneath, right? So if we have the equal to underneath, that means we actually can touch the line. So our line is going to be solid. So our line is solid if we have the greater than or equal to or less than or equal to. So if we have the equal to underneath. If we don't have the equal to underneath, so we just have greater than or less than, we can't actually touch that line. We make the line dashed so that we know that you can't actually pick a point that's on the line. Okay, and we will do that in an example so you know what I mean. Okay, so if there's the equal to underneath, it's kind of like how when we graph on the number line, if it has the equal to, it's a solid point. If you have the equal to, it's a solid line. You know how when we just have the less than or greater than, you put an open circle instead of a solid point? In this case, because it's a line, you do a dashed line. Okay? Now, inequalities also mean that it can be anything less than the line or anything greater than the line. So we do some shading as well. You shade the region either above the line if it's greater than or equal to, or you shade below if it's less than or equal to. Okay? And then we always want to check our answer with this stuff because since there's so many steps, it is possible to make a mistake. So you check your answer by testing a point that's in the shaded region. So the shaded region means that our answer is in this area. So if we pick a point, it should show up as a true statement. Okay? Let's do an example. Example 5. Here's what I want you to graph. Y less than or equal to 3. Okay, we have 3 choices here. Is this A, y equals mx plus b? Is it standard form or is it a special case? It's a special case. This is a y only. So is that going to be a vertical or a horizontal line? Just want to check some points. It is horizontal because the y is always the same. We could do 0, 3 and we could do 1, 3. Y always stays the same. So we would have 1, 2, 3 and 1, 3. So that actually is a horizontal line. My symbol is less than or equal to. So does that mean my line will be solid or dotted? Solid, because it has that equal to. So let's draw a solid line before we shade. Okay, so because it has the equal to, the line is solid. Now my symbol is also less than or equal to. So am I going to shade above that line or below that line? Below. So shade below the line. Okay, so what is this telling me? This is telling me that for this inequality, any point that I pick in the shaded area should give me a true statement. Okay, so let's actually do a check just so that we can verify this. So let's pick a point that's inside the shaded area. I like to use 0, 0 if we can, and since 0, 0 is in the shaded area, let's just use that. So 0, 0. Now here's my inequality, y less than 3. Do I care what the x is? Is there an x in there at all? No, so it doesn't matter. So we're just going to plug in 0 here. So 0 less than or equal to 3. Is that a true statement? Yeah. And we expected it to be because it was inside the shaded area. Okay. So what does this solid or dotted line mean? That means that my solution could actually be on the line. So let's pick a point on the line just to see what happens, if it does give us a true statement or not. I'm going to pick, how about 1, 2, 3, how about 0, 3? Okay, so I'm going to pick the point 0, 3 because it's actually on the line. And since the line is solid, we should get a true statement. So I just want to verify that we do. Okay, so the point I picked is 0, 3 because it's on the line. There's no x in this inequality, so it really doesn't matter what x is. I'm just going to plug in y. So that's 3 less than or equal to 3. True statement? Yeah, 3 is equal to 3, so it works. So I could actually pick any point on this line and it would give me a true statement. So that's why the line is solid. Okay? Make sense? Okay. 2 more examples and then we're done. So, example 6. Graph y greater than negative 1/2 x plus 2. Okay, is this slope-intercept form, y equals mx plus b, standard form, or a special case? It's y equals mx plus b, right? Or slope-intercept. So I'm just going to write that off to the side just so that we remember that that's kind of what it looks like. Slope-intercept or slope-int. So what is b in this one? Good. B is positive 2. So we're going to graph that up 2 and put a point. What's my slope? Good. Thank you. Negative 1/2. Okay, so from that point that I graphed already, I go down 1 and over 2 and I put a second point. It does not matter if your points are open or closed. We're just putting points so that we can draw the line. So just put points there like how you normally graph. It doesn't matter if they're open or closed. This is a greater than symbol, so is it a dotted or a solid line? Dotted. It's dotted because there's no equal to, so draw a dotted line through all of that. Okay. And to illustrate why it's dotted, we are going to test a point on the line. And this is greater than. So my symbol here is greater than. So is it above or below shading? If it's greater, it's bigger, so it's everything that's above. So shade the stuff above. Okay, so just to illustrate my point, I want to graph or check 2 points on here. Let's check one in the shaded area, and then I want to check one that's on the line, just to show you why the solid or dotted thing works. Okay, so let's test a point that's in the shaded area. How about 1, 2, 2, 2 is in the shaded area. Are you guys okay testing 2, 2? Okay, so let's check the point 2, 2. Okay, so y is 2, so that's going to be 2 greater than negative 1/2 x, which is 2, plus 2. So that's 2 greater than negative 1/2 times 2. What does that give me? Negative 1 plus 2. And 2 greater than negative 1 plus 2 is positive 1. Is 2 greater than positive 1? Yeah, so it works. So we did shade the right area. Okay? Testing a point is very important, so just so that you know if you shaded the right area or not, because it can very easily get mixed up with your shading. Okay? Just to show you why the dotted line actually works, I want to test a point on the line, and we'll see if we get a true or false statement. Both of the points that we plotted are on the dotted line, so I'm going to do 0, 2. Is that everybody okay with that? This y-intercept? So I'm going to test the point 0, 2, which is on the dotted line. So y is 2, and we want that to be greater than negative 1/2 times x, which is 0, plus 2. What's negative 1/2 times 0? 0. So this is 2 greater than 2. Is that a true or a false statement? That's false. 2 is the same as 2. It's not bigger than 2. So that's why we can't actually pick a point on the dotted line. Does that make sense? So if you don't have the equal sign, you can't pick a point on the line. So that's why we make it dotted. Okay? I just wanted to show you guys that you don't have to test all of these points every single time. Okay? Just wanted to show you why. So let's graph one more and then we're done. Okay? Last one. Two y minus 3x greater than or equal to 6. Okay, so is this y equals mx plus b, standard form, or special case? A special case is only y or only x. So this one is, well, we have x and y on the same side here, so it's in standard. It's standard. Okay, so we need to find the intercepts here. So I do my t-chart. I look for the x-intercept, and I look for the y-intercept. Even though y comes first in this one, x and y are still on the same side, so that's why it's standard. The only time it would be y equals mx plus b is if y was by itself. Okay. So to find the x-intercept, we cover up the y's. So that leaves me with negative 3x. And because we're just looking for a single point, you can change it to equal 6. That's okay. You're just looking to plot a point. So the symbol in this step really doesn't matter. Okay, so you can use an equals because we're just trying to plot a point. So we divide both sides by negative 3. And that gives us x equals negative 2. So we just plot that point, 1, 2. Then we do the same thing to find the y-intercept. So we cover up those x's, and we're left with 2y equals 6. Divide both sides by 2, so y equals 3. So we just go from 0, 0, up 3 spaces. And so the only reason why I changed the greater than or equal to an equal sign is because I'm just plotting points. That's all I'm doing here. Okay. So we have greater than or equal to, so is that a solid or a dotted line? Solid line, so draw your solid line. And since it's greater than or equal to, is it shaded above or shaded below? Greater than means it's above, yep. So just shade a bunch of stuff above. Okay. And we're done.